in my opinion, a chainsaw is much more dangerous. Yeah, but actually this is exactly what we have done with the M100.
So, welcome Jan. Thank you for your openness to give us your view on the FloRe company, what your experience is here, what you do here. First, maybe you can introduce yourself to give the audience the chance to know who you are.
Thank you, guys. Thank you for the invitation. Yeah, my name is Jan Flohre. I'm 38 years old. I'm married. I have 3 children, and I'm a physicist. And yes, now I'm working for FloRe.
Okay, so you are a physicist. Is there any other step in your education that you want to mention?
So yes, when I started my studies in the RWTH in Aachen, it was I liked it. But then when I finished these, I went to the Forschungszentrum in Jülich, and there I started my PhD. In the field of photovoltaics, and after that, when I finished that, I did a postdoc there for around 3 years, and then I hired here for FloRe.
So you worked on photovoltaics. That means that was the time where you got to know FloRe, or was it later when you looked for a job?
Yeah, it was interesting because really during my time at the Forschungszentrum, we had a project with FloRe, but actually I was not involved in this project. So I just knew, okay, there is the company FloRe and they are dealing somehow with lasers, but I never thought of really being an employee in FloRe. That was very interesting in the end. Yeah. But it was the first time I got into touch with FloRe during that time.
So you've known the company, but you didn't work with FloRe at that moment. So what was the reason why you decided for FloRe then?
During my work at the Forschungszentrum, I was really doing basic research. That was very interesting. But I never saw a product or anything that I could hold in my hand or something what was relevant for the industry. And I was missing that. And then I was thinking, okay, which is the way to go? I really liked the semiconductor technique, but I was also always interested in laser technique. So then I was looking for the companies which we have here in this area.
Yeah, which combine these things.
Which combine these things, and I decided to go more in the laser technique region, and then I applied for a job at FloRe.
Oh yeah, sounds really like a good match for you. So yeah, then you started at FloRe at which year was it?
It was 2018.
2018, 4 years ago. What is your role at FloRe? Was it? Did you start with your current role? Tell me a little bit about the last 4 years.
Yes, so I started at FloRe as an application developer. So I was doing a different application in the lab. I was searching for new laser processes in the lab, but also I had some research projects with FloRe and universities. I was going to fairs, but I was starting as a usual application developer, which we have a lot of them here at FloRe, because we have many application labs. And during that time, FloRe was growing, and also our team was growing. And after 2 or 3 years, then I got the leading position for our team, and now I'm the head of the process development of the FloRe technology. And I have a second position. I got also the responsibility for our JETLASER as a product manager.
Okay.
And this is what I'm now.
So it's more than a double role: project manager, team leader, and I'm sure, as I hear you, you like to also work in the lab and making experience on your own. Can you explain me how your week or your typical week is. So many different roles, many different targets you want to reach.
Yes. So typically, I'm just coordinating our team. So we are with me. We are 5 people, and usually we do lots of applications in the lab or acquisitions, and we get these acquisitions from the sales department. So customers come to us and ask for a certain or have certain problems. And then I'm coordinating these acquisitions. Sometimes I do them still by my own. But this is one part of of my usual work, and the other one is coordinating the handheld laser cleaning products, the JETLASER. We have 4 different cleaning units with different power levels. It's starting with the JETLASER M100. Then we have the M200, M500 and M1000, and the value behind the M is the laser power it has.
Let us stay a little bit on your team. What is your team working on? What is the topic of the team?
Yeah, so our team, the 4 people who are working in my team, they are all mechanical engineers. They studied also in different universities, but it's a very new team. And what they are doing is they build up laser processes. So you can imagine we have different laser sources in our lab, and typical work is if the customer has a certain problem, he comes to us, and usually he needs a paint to be stripped from a work piece, or rust needs to be removed, or a certain thing what needs to be cleaned.
Whatever the customer.
Yeah. Whatever the customer needs, and then we go to the lab. We think about which laser could fulfill these requirements, and then we are really searching for getting a laser process which is working. Afterwards, we write a report. We share it with the customer, and if that satisfies him, then in ideally case, he brought a machine from 4JET.
Okay. So Jan, now you are already much in detail for different versions and so on, and I'm really interested in much details about the JETLASER. But first, give the audience the possibility to understand what the JETLASER is. What can you do with this machine? Is it a machine? You said handheld. Explain it a little bit.
Okay, yeah, I will. The JETLASER is a special machine for 4JET because it's a handheld laser cleaning machine. Sounds a little strange, and when you want to know how that works, just imagine a pressure water cleaner, and now think about this water cleaner without water but with laser light. And this is how our JETLASER handheld cleaning system is working. So you really can clean different surfaces with laser, with light.
Is the laser process comparable with a water jet pressure cleaner? So just with brute force graving through the dirt until you reach the surface, or are there differences?
No, there are differences. Sometimes it is the same, it is nearly the same, but there are definitely differences. So the laser cleaning itself is a process which is possible to perform especially on metal materials, and the water cleaner is more for removing dirt from wood or stone or whatever. And laser cleaning is really a very, very special process.
Why is the metal surface typical for laser application, laser cleaning?
Yeah, that's due to the fact that metal has a high reflectivity for the lasers we use, the typical cleaning lasers, and so the laser does not damage the metal surface. And this is when you do have cleaning applications, it's really key to not destroy the base material usually.
Okay, that's the reason for metal, and that means other materials it sounds like it's also possible to clean them, but you need to find out or how you handle different materials. I'm sure many customers want to clean different materials.
Yeah, it's correct. So you're not limited just to metals. You can, with a laser, you can also clean different materials. You can also clean, for example, wood. But it always depends on the wood, if it's a hard wood or a light wood, and also on the residues which you have on the surface which you need to be clean. For example, imagine there is a paint coating on the wood. If the laser is not absorbed in this paint, then it will not remove this paint. And on the other hand, if you clean a wood or if you laser treat wood, sometimes the laser beam is absorbed very extremely inside the wood, so it gets warm and hot, and then you have burning marks, for example, on the wood.
Yeah, interesting. Now I have different topics in my mind. Let me start with the strategic part I'm interested in, because as many people know, Forjet is typical building huge machines, laser class 1 machines, inline, full automated. What is the reason behind that you now making more handheld things? It's breaking the focus, or maybe.
It looks like it's breaking the focus, but in the end it is an advantage for the product range we have. And you are totally right, you mentioned all of our machines are laser class 1 systems. That means that they are very laser safe, so the operator does not need to wear personal safety equipment. You can just operate the machines without any care for the laser, because everything is encapsulated. With jet lasers, a handheld cleaning unit, this is not possible. So the operator always needs to wear personal laser safety protection, because the laser beam comes out of this system. Sounds dangerous, but if you care for laser safety and wear laser safety goggles, then it is a very safe system.
Sounds really dangerous from my point of view, because the light from the laser is invisible. Okay, your eyes are protected by the goggles, but you can still burn your leg while moving or something. Maybe you can compare with a chainsaw or something. Is it comparable? For me, it sounds more dangerous.
I like the comparison between a chainsaw and a laser cleaning system, because in my opinion a chainsaw is much more dangerous, because you can lose your leg very easily with a chainsaw, or your arms or your finger. It's you need to very good operate this system, and there is a lot of torque on it, and you need to be strong when operating a chainsaw. A laser itself has a high energy density when it is focused. So imagine you focus the laser beam onto the surface, and just in the focal plane you have very high energy density, and that is where you have the interaction with the material you need to remove and or to strip, and the laser beam itself. But if you are far away from this focus point, then the laser itself is not so dangerous anymore. And if you have personal safety equipment, like if you're wearing the correct clothes and if you have the laser goggles, then it is not so dangerous, because it's very, very easy to hand this system. It's not so heavy. You can hold it easily in your hand, and you have usually a very good visibility to the points where you are working, and then you can work very safely. You just need to know what you are doing. You need to know the laser safety instructions, and if you then shield the environment so that no one can enter the room or the restricted area where you are working, then it's a very safe technique to work.
And if you have experience, then you know how to handle. I know laser processes, and I know you have a team of 5 guys who are developing laser processes. How hard is it to handle, to get the laser experience, not only the safety part, to get the experience I have a dirty part, maybe the operators will shoot with too much power because they do not have the experience like you have in the laboratory.
Yeah, so there it always depends on the application. If we are just talking about the handheld systems, there you easily get used to it because there are not so many parameters you need to change. You can change the pulse energy of these lasers, which results in a certain energy density on the surface. Usually when we do applications and we do not know if it's working or not, then the operator starts with a very low energy density to not destroy the base material, whatever it is, of the workpiece or so. And then one is increasing the laser power or the energy density in the end, and until the whatever needs to be clean is cleaned, and so with that you can avoid of damage the material.
Is there also part of software combined with this handheld machine, or do I need to do the tests? How much power do I need every time, or can I save the parameters?
Yeah, so there is a software, and you can also load recipes. So what we have done with the system is we gave different recipes for different applications. For example, mold cleaning, typical mold cleaning from a steel mold. If you choose this recipe, then the laser settings are in the way that you will not damage a steel surface. But you can also choose the recipe, for example, for aluminium cleaning, and aluminium is different compared to steel when cleaning, and then you have different parameters for that. And you just choose the recipe, and then you are very safely to not destroy the material you are working on.
Now we are already talking about operating with the machine. Who in the world is needing the machine? For who did you build the machine? Is it like I can buy it in the construction market and use it on my own to, I don't know, clean my car or something?
At the moment, you cannot buy it in a construction market. It is a special tool at the moment still, but it is very good for especially doing mold cleaning. And there are a lot of companies who are doing mold cleaning who needs to clean their molds or their tools. These companies, this is the companies we want to address with the laser. And often it is in the way that these companies just need to clean their molds, like let's say once or twice, maybe fourth a year. So for them it is too expensive to buy a cleaning system, and therefore we address more the service people who then brought a system and go to the company which do need to clean their tools or molds.
Okay, that's a pity. No jet laser in my garage next year.
Not this year.
Okay. Thank you for the overview details. What is the machine like? We started at the point that you leaded a project to develop a new jet laser type, the M100. Now you're saying you're leading a project, but it sounds like just a little bit downscaling. Yeah, the smallest, now you have the smallest version of the machine. Was it like only downscaling, smaller laser?
No, it was not only downsizing. Let me explain a little bit the differences between these units. So we have four different jet laser systems, but actually it's just two platforms. We started with a large platform from 200 watts to 1000 watts, and these are pretty large systems. They have a chiller inside, so the laser needs a water cooling, and these systems are ideally for doing especially mold cleaning. So their laser is not damaging the metal surface. We choose a special laser source for that, and it's really brilliant working. But there are certain applications where you need, in the end, a higher energy density. Let's say you need a more aggressive beam. And for that applications, we designed a new machine, and we were thinking, okay, what is the needed in the market? And we found out it's a small a smaller laser, it must be more compact, more flexible, and it needs to have a bit more an aggressive laser source.
Okay, I understand. So many requirements have changed, so was not possible to scale it down.
No.
Makes more sense to, yeah.
Really to develop a very new system.
Is there something very interesting, a big happening that you remember from this project phase?
Yeah, so in general, what was very interesting during that project was we really developed from the base. So we were searching first for the correct laser source. We were also searching for correct scanning unit or laser deflection unit. And you always have to think if it's that the whole system needs to be light. And we were building different prototypes, and with each prototype we learned and we thought things which we could improve. And in the end, we had a prototype which was working and was we were all satisfied with that. And for me, the best thing was when we finally had a product which also had a very nice design, because we had also the chance to have a designer who was giving us some information how we can improve the look of the system. And when we had the final product, to see our clients and agents that they are satisfied while working with the system.
You worked with a designer together, and now I'm thinking about how heavy is this, so that the designer needs to think about how to handle this weight in your hand.
It was a very interesting project to work together with a designer, because he does not have so much the technical view on the things. So we had to explain first of all what is laser cleaning, what is the needs for a laser. We had to explain him that you have a fiber that you cannot just easily disconnect it from the station wagon. But it was very good to get also a feeling from a person which has nothing to do with laser cleaning or laser technique at all. So it was a very good relationship between us, and we got in the end a very nice result with new improvements where we did not thought about it at the beginning.
Allow me a last question to give the laser specialists in the audience the technical laser perspective of the difference between these two machines. So why can a smaller laser engrave and a bigger laser cannot?
Yeah, it sounds a little funny to say, okay, the low power laser with 100 watts is more aggressive compared to a 1000 watt laser. But that is due to the laser technique, the so-called beam profile of the different laser sources. And to explain the difference, it makes sense to write a little sketch. So let me get that notebook. And I will show you the energy distribution in the spot. Okay. So we have the energy on one axis, and we have the distribution on the other one, so the x-axis. Here, this is the energy. This is just distribution for it. And for the M100, we have more a Gaussian, or we call it a Gaussian beam profile.
Okay.
When you now think about you want to ablate a certain material from a metal or whatever, you need to exceed a certain threshold to really remove material. This threshold might be somewhere here. What now happens is that just the intensity or the energy which is over this threshold can be used to clean. And that means just this part of the laser source is really used. The rest of it, so the sides here, they are just transported or transformed into heat on the surface itself. When we look now to the different beam profile, this is the so-called more top head beam. When we see here the top head beam profile, the energy distribution over the spot has this kind of shape. So it's increasing, it has like a plateau, and then it is decreasing again. So there is a very homogeneous energy distribution in the spot. And if you now have a look for these thresholds to remove the material, you can see that much more of these of the pulse can be used for really cleaning. You just lose less on the sides of the laser spot itself. And now, what happens when you want to remove metal, when you want to structure metal, for example? What you do is you shoot little spots into the material. But to evaporate metal or to melt metal, you need this has a very high threshold. So let's say this threshold is somewhere here. That means with the Gaussian beam shape, you can exceed this threshold, and this part here of the beam, this can be used for structuring of the metal.
Okay.
But when you have the same threshold here in this top head, this might be on this position. You will never exceed it, because you just have this homogeneous energy distribution in the spot, and this is why you never exceed the threshold to damage the material, and therefore you do not harm the material.
Yeah, thank you for the explanation of the difference. So because you are changing this beam profile behavior, brings that more advantages or disadvantages? Maybe, yeah. It's more dangerous that you hurt the surface when you do not want to hurt.
Yeah, definitely. There are other changes as well. Let's first say something about. You said it's dangerous to the surface. You are right, but don't think that here this beam profile is just dangerous for the surface, because we will always harm the surface. Yeah. It is also possible to decrease the pulse energy. That means then that the whole curve will decrease, so you will not exceed the threshold anymore. But let me go more into detail with these for this characterization, because there are certain differences which come with these both beam profiles. The relevant number which characterizes these beam profiles is the so-called m², and the m² for an ideal Gaussian beam profile is 1. And the m² somehow characterizes the ability to focus a beam. And for top head beam profiles, we always talk about top head if it's much larger than 2. And typically our laser sources have m² of 10, 20, 30, sometimes it's 60 or 80. But let me show what it means to have what is the ability to focus the beam. If you have a raw beam, imagine this is our raw beam, comes from the side, and then we want to focus it. We have a lens, and if we have here a beam with a Gaussian beam shape and an m² of 1, then we will have something like this. So this is our focus. Here in the middle, this is our focal spot. And then we characterize the tolerance of the focus with where the area of the spot has doubled. This might be that might be somewhere here, and this is an important value for a handheld system, because you always need to keep the focus. If you are not working in the focal plane of the laser beam, then there is no interaction of the material with the laser, and you cannot clean, strip, or whatever you need to do. So this is a very relevant number for
that's
a handheld cleaning system.
Compared with a water jet cleaner, if you are too close, you maybe damage something.
Exactly.
It cannot happen because the energy is decreasing if you are on the wrong distance.
Exactly.
Yeah, interesting.
So the energy is decreasing if you are too far away, but interestingly, it's also decreasing if you go closer. So it's just working if you are in the focal plane. So, and now imagine for an m² of 1 laser source, usually this tolerance is in millimeters or even sub-millimeters. It depends a little bit on the setup, on the optical setup. And when we now have a look on what happens when we go more to a top head beam shape, this is here for much larger than 2. Again, we have the raw beam coming in, we have a lens which will focus the light, and then the focus looks something like this. And what happened is the focus itself, it's much larger. Even though here it's the same lens, the focus for a top hat laser is much larger compared to a focus of a M²1 laser. And also the tolerance, so the region where the area has doubled, this might be somewhere here. So this region, we call it Rayleigh length, is much larger compared to the Rayleigh length of a Gaussian beam shape. So and now, since this is gives you a lot of advantage while cleaning handheld, because it gives you more flexibility, you always like to work with top hat lasers because it's really just easier. Yeah. And therefore, then the challenge for the M100 was to find the trade-off between to have a aggressive laser which enables to structure material, but also gives you enough tolerance to work handheld. And there we find a laser source and an optical setup which fulfills all these needs we had, and this is then the source and the optic we choose for this system.
Yeah, interesting, understood. So you now describe the two extreme situations that are possible, Gaussian or top hat. Did you think about to choose a laser which is in between to have maybe all advantages?
Yeah, but actually this is exactly what we have done with the M100. So we don't have a perfect Gaussian beam. And in the end, a perfect Gaussian, this is just physically possible, but technically we never had the perfect Gaussian one, but we come very close to a perfect Gaussian. But for the M100, we choose something which is not really Gaussian. It is really something in between that. And this is then the advantage to combine both.
I'm at the end of the questions about the current situation, what you are doing here. Thank you for that. Now I'm interested a little bit a dreamy view on your actions maybe around the M100. It's a current project. What do you think about in 10 years, 20 years? Finally, in 30 years, maybe I can buy one in the construction market and have one in my garage?
So that sounds a little funny, but I think this is really our future. So laser technique at the moment is expensive, but it is comparable to other techniques, and laser prices are drastically decreasing in the last years, and the laser power is increasing since many years. And in my opinion, in the future, you can hire these systems in the construction market or from some companies, and I think also you will use them in your house, maybe for deep painting your windows or whatever.
Cleaning my barbecue grill.
Cleaning your barbecue grill, exactly. So I think in the future you will see laser cleaning systems everywhere, and people will get used to it.
Finally, my last question is not really about work, but a little bit. I want to ask you for 5 buzzwords to the topic ForJet. Just the first things you get in mind.
Okay, so when I think about ForJet, when I think about why do I like to work at ForJet, then it's definitely the team play and the collegiality we have. So this is really the thing that is, for me, it's most important. But then we are also very innovative. So innovative is the third one. And we are dealing with lasers which are very good for the environment, because we change old products which are very bad.
CO2 footprint maybe, or something like that.
Exactly. We have a very low CO2 footprint, so therefore sustainability is a buzzword. Okay. Maybe the last buzzword is high-tech.
Okay, just without any comment, high-tech. Yeah, okay, then thank you for the last 5 words. I will confront our boss later with some of these, and I'm excited what he will say about it. Thank you.
Thank you, Kai, for the interview.